With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so in this particular question, imidazole is given, that is a building block of essential amino acid, which is histidine. Essential amino acid indicates that it should be present in our diet, okay? When it reacts with water, out of 4 given possible products, which should be the predominant product? Okay, so it is asked that when imidazole reacts with water, what should be the possible product? Okay, so I am drawing one imidazole ring and will explain to you that what happens in an imidazole ring when it reacts with water. So imidazole ring has 6 pi electrons. Now, why did I say 6 pi electrons? These 2 electrons which are on this particular, let's say this is nitrogen number 1. These 2 electrons which are on nitrogen number 1, they are involved in delocalization, and the nitrogen here is sp2 hybridized. Okay, this nitrogen here is sp2 hybridized. It has also one hydrogen, which I forgot to mention. Okay, so it has 3 bonds, yet it is sp2 hybridized, since these lone pairs are lying in pure p orbitals and they are involved in conjugation. Very well. So these 2 electrons, and these 2 electrons together make it a 6 pi electron system, and it is therefore aromatic in nature. Okay, and the electrons which are located on this nitrogen, let's say we are naming it 3, on this particular nitrogen, these are lying in hybrid orbitals. Okay, these lone pairs are not in pure p orbitals, these are lying in sp2 hybrid orbitals. Okay, so out of nitrogen 1 and nitrogen 3, which is more basic? 3, because these electrons are not available for donation, these are involved in conjugation. However, these 2 electrons, they are basic. So N3 is what? N3 is basic in nature. N3 is basic in nature. However, N1 is not basic. So this is the fundamental difference in the imidazole structure. Okay. So now, since we have came to a conclusion that N1 is not basic and N3 is basic, so if N3 is basic, if this is basic, then it can donate its electron to H2. Like if we are going to see some reaction happening here, so let's write down quickly. Okay, so now this has electron, this is basic in nature, so what it can do is it can what? It can abstract this H plus, okay, and like this. So the reaction becomes this, wherein nitrogen now has acquired positive charge because it has donated its electron to whom? To H plus. So this is now the structure, and this is one of the very dominant structure which would be present. Now, why am I saying that this is dominant and not anyone else? Like each product could have been formed, but we are asked to identify the predominant product. Now, look closely. Predominant product indicates the product should be stable. The product should be stable enough, isn't it? So everything which is mentioned as 1, 2, 3, 4 will be formed. Okay, but which is going to be more stable? This particular 3. Now, why 3 is more stable? Because 3 is aromatic. It has still aromatic character, in that the aromaticity is still intact as it was in imidazole ring, because now also 1, 2, 3, 4, 5, 6, all 6 electrons are present in the ring, and nitrogen has acquired positive charge. So aromatic structures, okay, aromatic structures having 4 and plus 2 pi electrons, having planar structures, these are most stable. So there is a trick whenever you are asked to identify that which is going to be the predominant product, you would definitely look on to more stable product. And out of these four, aromaticity rules here. Aromaticity brings the stability. Okay, aromaticity brings stability. And what are the key features to an aromatic structure? 4n plus 2 pi electrons, conjugated system, and planar structures. Okay, the electrons which are in conjugation, that should be in one plane. Okay, so let us look at all the rest options. So this will be formed. Okay, this can be formed simply by just this attack on this double bond. Okay, these all can form, and this also can form when this lone pairs. Okay, these lone pairs will go under drastic conditions, but it is also one of the possibility. But to be on point, to be correct, this structure, okay, structure number 3 is most possible structure. I hope you found this useful. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.